Okay, so let's look at this. This is on the next page, and this is just asking some questions based on a graph. And I'm only going to go through one, and hopefully this will be helpful for you so that you can answer the questions on the other one. Number one is referring to this graph right here. So we can see that we have an upward opening parabola. We see that the vertex is right here. This is the vertex. So I just like to go ahead and examine my graph. And it looks like it is at 2, and then this is down 1, 2, 3, 4, 5, 6, 7, 8, 9. So the vertex is at 2, -9. And I see that the y-intercept is at 0 and -1, 2, 3, 4, 5. All right, so I just like to kind of pick out my key features. Here's an x-intercept, and here's an x-intercept. So that's very important. So it's really nice because all of our key points are hitting at lattice points, so we can read them. They're going to be whole numbers, integers. So for these problems that are not real world problems, our domain is going to be all real numbers. If you recall, in this problem here with the Wile E. Coyote, our domain, even though there was no question that asked about it, our domain for this problem would be x value is greater than or equal to 0. But we have just a general case here, so our domain is all real numbers. Our range comes from the y values. And so I'm going to use change colors here. And if you notice, if I start drawing lines from my graph over to my to the y-axis, the first y value I hit is here at -9, which corresponds with the y coordinate of the vertex. And so then the y value is getting larger. So the range is going to be all the y values. It's opening upward, which is another reason why it's going to be greater than, and then or equal to -9. All right, so I think I forgot to tell you guys greater than or equal to before. We were just doing the greater than, but it should be greater than or equal to. For the extrema, I just want you to tell me, is it a min or a max? All right, so it's an upward opening parabola. I'm going to erase this part so that it's a little cleaner. All right, so it's an upward opening parabola. Here's our vertex down here. And remember we talked about valley, low. And so it's going to be a minimum, right? The axis of symmetry is that invisible dashed line that goes through the vertex, and it goes through the x-axis, and it's hitting the x-axis at 2. The axis of symmetry is always written as the equation. It's always going to be x equals this number, and it corresponds to the x-coordinate of your vertex. So your axis of symmetry comes from here, and your range comes from here. So that's a good note for you to write down and put on your note cards when you study and have that memorized. So x equals 2. The x-intercept. So x-intercept is an ordered pair. Here is one and here's the other. To get to here, I always start at the origin. I'm going left 1, and I don't have to go up or down, so it's 1, 0. And then my other intercept is here. I go back to the origin. I count 1, 2, 3, 4, 5. And so that ends up right here. So that's going to be at 5, and there's no motion up or down, so it's 0. And remember that the y coordinate of the x-intercept is always going to be 0. And then the y-intercept is right here, okay? So that's the y-intercept. And so to get the coordinates of that point, remember, I don't go left or right. I go straight down. Remember that the y-intercept occurs where x is 0 always. So the ordered pair for that, as we said earlier, would be 0, -5. Now, I want to clean this off so we can talk about this next part, intervals of increase or decrease. Right? So I'm erasing all that. And remember, with this video, you can pause it, you can rewind it, you can replay whatever you need, so that if you missed anything or you want to hear it again, you can do that. So for increasing, think about the word rising. So the interval of increase is the side of the graph that's rising, and the decrease is the same as falling. Okay? So the vertex is what divides the parabola into a rising side and a falling side. This is what we call a turning point. The direction of the graph is changing. So to figure out what's happening on the left side, and let me just add the axis of symmetry back. To figure out what's happening on the left side, I'm going to, okay, so I'm sorry I had to pause, so let's come back. So imagine if you were walking along here, okay? So I'm just going to draw a little stick figure, okay? And you're walking along here, and then you hit this point. So if you were to continue, you would end up dropping, all right? So this side is falling or decreasing, all right? And so then there's a turn at this point, and then it begins to go off or go up. So this is rising or increasing, okay? So the turn is happening at x equals 2. So that comes from the x coordinate of the vertex to -9. So this number right here is going to help us define our intervals of increase and decrease. So it's decreasing on the left. So I'm going to do this one first. I always start with x, okay? And so the left side of any number along your x-axis, any number to the left of something is always going to be small, or be getting smaller, I should say. So those are all the numbers that are less than 2, the x values that are less than 2. All right, so it's decreasing on the left side of the axis of symmetry. And so that's x less than 2. So it's increasing or rising on the other side. So on that right-hand side is x greater than 2. So the note that I would take from this is that if it's on the left side, if we're talking about the left side, whether it's rising or falling, we're going to say x less than some number, and that number is the x coordinate of the vertex. And anything that's happening on the right-hand side of the vertex and the axis of symmetry, then that's greater than, so that would be x greater than a number. And again, that number is coming from the x coordinate of the vertex. And then almost done here, we're looking at the end behavior. So remember how end behavior, basically the not so mathy way of looking at end behavior is just looking at what the arrows are doing. And so on either side of this graph, as x is increasing, okay, y is also increasing. And so I know we talked about looking at the signs, okay, of numbers or points in each one of these quadrants. But the main thing is to remember right here, as x is increasing, getting bigger, approaching positive infinity, y is also getting bigger, approaching positive infinity. And then as x is getting smaller, which means it's approaching negative infinity, the y's are still getting bigger. In other words, it doesn't matter if you're moving from left to right, the y values are getting bigger, or if you're moving to the left, your y values are still going up. The parabola is going up, 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 up. So these are always going to either be both positive or both negative. The only reason they would be negative is if we're dealing with a downward opening parabola. But since this is an upward opening parabola, we want both of these to be positive. And then the average rate of change, just remember, average rate of change is a slope, okay? And to find a slope, I need to use this formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so that means I need some ordered pairs. Remember, this is an x, and that's also an x, so I need some y values. This seems to give students a little trouble, but all I need to do is go to my graph to get the y value. So I want to erase this so it's a little cleaner. We're almost done. I thank you for your patience. I thought this would be done in 10 minutes. I'm going to go a little over, but I think that's okay. All right, so let's find 0 on the x-axis. So here's the x-axis, here's 0. So to get to a point on the graph, I would have to go down since the parabola is down here, and I stop here. And what are those coordinates? Oh, that's my y-intercept again. So this is 0, -5. So that's one of the points I can use. And then I have a 1, so I go to 1, and then I start dropping down until I hit the parabola. That looks like that's going to be 1, -8, right? So that's my other point. So I'm going to put both of those points into the slope formula. So remember, y is on top, x is on the bottom. So I have -8 minus, because the formula has a minus sign, a subtraction sign in it, a -5. So I have to put both the subtraction sign and the negative sign, all right, over. So I've subtracted the y's on top. And I'm going to subtract the x's on the bottom. Now remember, keep change. So -8 minus the -5 becomes -8 plus 5. Need some room there. So -8 plus 5 over 1. -8 plus 5. Pick up your calculators. It's okay. Tell mom and dad we said it's okay to use your calculators now. All right? And so, because we don't want anyone getting this wrong just because of a sign error, right? So that is your average rate of change, AROC. Remember that from a previous unit? So, ladies and gentlemen, that's it. Use this video to help you do number 2 and number 3 on here. Make sure you're studying every day. Alrighty, goodbye.